Here's part C of number 2 in chapter 13. In part A, we previously wrote the rate expression for the change in concentration of different reactants and products. We're not interested in nitrogen in this problem, so I left it out. In part B, we determined that the change in oxygen concentration over time was 0.0072 molarity per second. And in this part, I'm going to explain how to calculate the change in nitrogen concentration over time. Okay, so we're basically going to be using this part of the rate expressions, which is an equation. And we're going to solve for this quantity here just by multiplying both sides by 2. We have this whole quantity here, which is 0.0072 molar. So let me write it out in a little bit of detail. The change in N2O concentration over 2 times the change in time is equal to 0.0072 molar per second. If you're not sure where I got part B, watch my other video. We're just taking this value and plugging it right into the right-hand side of this equation. Okay, so all we need to do here is multiply by 2. And so the negative change of N2O concentration over change in time is equal to twice that. And it makes sense just looking at the chemical equation. If we think about the change in concentration of oxygen, okay, the change in N2O concentration is going to be twice as much because there's a 2 here. Okay, 2 of these go away for each one of these that form. So the change in concentration over time is going to be twice as much. Now to get rid of this minus sign, we basically just multiply both sides by -1. And so the change in N2O concentration divided by change in time is negative 0.0144 molarity per second. So why is it negative? Is that correct? What's going on there? Well, the negative sign just means that the concentration decreases. Remember in part A we put a minus sign above the chemical reactant. This suggests that the concentration decreases in concentration. So it goes down by 0.0144 molarity each second. So that's how you do part C. Thanks for watching.